Hello, welcome everyone. Welcome. We are thrilled to welcome you to this kickoff webinar for the Grey Scott School 2026. I am Marie, and with Karim Mazoum, we are part of the French Competence Center within the EuroCC project, and we are co-organizing this event with Pierre Aubert and the lab in Annecy. So this year marks the 4th edition of the Grey Scott School. Last year was a great success. We moved fully to English and welcome participants from across Europe and beyond. And we hope you'll be part of the journey with us this year. In 2026, the school will again run for 2 intensive weeks focused on CPU and GPU computing. You can attend online, on site in Annecy in France, or from one of our satellite partner locations. In fact, becoming a satellite site is very simple. You'll see it's free, it's fully turnkey, and we provide all the material. You just host the sessions at your site and can open them to your colleagues, your students, your users, or clients. It's a great way to share high-level training locally and highlight your organization within the HPC community. So if you are interested, just feel free to reach out. Then today also marks the launch of the 17 Grey Scott Thursdays. It's a series of weekly webinars leading all the way up to the school. So if you enjoy the formats, we'll be seeing each other every Thursday. And please spread the word around you. This will really help us. And the more people join, the better the experience for everyone. There's no limits, everyone is welcome. And now, Pierre Aubert, the creator of the Grey Scott School and researcher at the lab, CNRS, will walk you through the full program and all the details of the 2026 edition. If you have any questions for him, for us, please use the chat. Now, Pierre, it's over to you.
Thank you, Mary, for the introduction. So today I will present to you the Grey Scott 2026 school. So mainly we will compute some stuff on heterogeneous hardware. And to introduce the school, I have first to introduce the actors of the school. So first, the Reprise project. So it's a transversal project in 2P3, so the particle physics and nuclear physics of CNRS. So are about 20, 30, depending on the year. And what we do mainly is to follow our favorite languages, so C++, Rust, Fortran, and Python. And also we use a lot of tools, so performance test tools, so Valgrind, Macao, Perf, VTune, stuff like this. Some precision with KADNA, containers with Aptainer, Singularity, Docker, Podman, Kubernetes, stuff like this. And also we use and we try to get update with a lot of softwares. So Extenso, HPX, Alpaca, Cocos, Vulkan, CUDA, HPC SDK, OpenCL, OpenSCC, OpenVINO, and many more. So we have also TBB, we have also all this kind of stuff. So the idea is to really push the boundary of what we can do and to get update of all these frameworks. So everyone is following this favorite framework, and we try to put everything together each year to bring you a new school. So in terms of hardware, we use CPU, GPUs, and FPGAs also, multi-core, many-core approach. And in 2023, we start the first school, the revamp of one school, in fact, of 2016. And then we get approached by TerraTech. So I have to introduce a bit TerraTech. So TerraTech is an association, and their goal is to do some valorization, dissemination of knowledge, so mainly with schools, seminar, and interviews. So if you see a calcul list or the devlog list or stuff like that, normally you should see a lot of schools, a lot of seminars during the year. And their goal is also to make a bridge between the academy and the industry. And they are the French antenna of the formation of the EuroCC formation catalog of HPC, HTC, HPDA, and quantum computing with 33 other countries And this is the formation part of row HPC that you might know for Chineka, for Urlich, for Surf, all these big computing centers in Europe. And they said to us, okay, it's nice to have 30, 40 people in a school, but 200, it's much better right now. So let's try. And we tried that in 2024. It was a success. And in 2025, we tried to do the same in English, as Mary said just before. And to give you some figures, some statistics of 2025. So it's a 2-week schools. We have 9 teachers, 17 webinars, almost weekly from January to June. We have some day out in the French calendar, but roughly it's a weekly rendezvous. And then we have more than 5,000 views on YouTube, so it's quite interesting for people, I guess. 3 connection mode, I will give you some details after that. 15 satellite sites for 2025, 51 countries registered. So basically from America to New Zealand, and we have 31 countries on Discord. So the other we cannot check because it's on YouTube, so we don't have the locality of people who are following, and 19 in Europe also. So roughly 500 unique attendees on the school, 80% of academia, 17% of industry, and 3% of authors, maybe for curiosity, stuff like this. About 200 people connected each day, 930 people on Discord, so quite active community. In fact, it's a bit fun. Some people are doing the lecture in a shifted way. So we had some question in October, for example, for the school, for the summer school. So it was a bit nice also to have that. Roughly 100 containers, a bit less than 100 containers. So each lectures are several containers compatible with Docker, Aptainer, Podman, Kubernetes, OpenStack, all your favorite container stuff. Normally, everything should be okay for x86 and AMD64, and also ARM for 2025. So there's a newcomer in 2035. So you can follow the lecture on laptop, on a remote server, with htconda, with Slurm, so if you want to use some scheduler, with Intel, AMD, and ARM infrastructure, no problem. So this year, this summer, we had something like 90 hours of live stream lectures, so it's quite intensive. We had something like 9 hours, 40 minutes of live each day, so it's quite a lot. So at the end, we have 82 videos after editing. So we have the lecture, we have some interviews, so teachers interview, attendees interview. So if you want to check that, I will give you all the link at the end of the presentation. We have 1 Bootstrap day in Nancy and in Toulouse. So the idea is the attendees come with their problem, with their software they want to improve, and we do our best to help them. So the idea is to have this interactive part also. And we have also 1 extra day in Annecy, so on Saturday between the 2 weeks. So with a little hands-on on different subjects made by Sébastien, and a discussion also where all the teachers are on the stage and you ask us our questions. So this is not live, so it's not recorded, it's not live, it's just a chat between us. So so we try to be as honest as possible because it's also the point. And so I can announce the next school. So from the 22nd of June to the 3rd of July 2026. So if you want to have a look, also I will give you all the link at the end of the presentation. So let's speak a bit about the program. So we will start, as always, with simple example. So Adamar product, of course, reduction, dot product, matrix product. So the idea is to show you how does it work, how we can optimize it. But of course, it's better if you use VMKL, Eigen, Armadillo, Eve, NumPy, Numba, because it's quite common to have this kind of BLAS once you want to compute. But of course, the problem is life is not made of matrix products, so we have to have a bit advanced example, I would say. And this is the gray Scotch reaction. So the name of the school directly is the name of the reaction. So you can see that as a chemistry game of life, if you want. So we have 2 species, U and V. And once you have enough V around you, V transforms U in V. It's quite the same in the game of life. You have 3 white cells around the black cells, and the black cells becomes white. So the dead cells become alive, if you want. And then we have a decay of V to a P product, which is not interacting anymore. So we can describe that with 2 differential equations, 2 coupled differential equations. And then we have, so U and V, the concentration of the species U and V. We have the diffusion rate of the two species. We have the kill rate when we convert V to the P product, so the non-interactive product. A feed rate when we add U and we suppress V and P. And the Laplacians for V and for U. So mainly the neighbor axis of the cell. So we have one cell and we want to have the gradient between the one cell and the neighbors. And the point of this reaction is to have something really easy to understand. You see, it's really simple, but it's really difficult for the compiler to optimize everything. So we can have lots of high speed up, and it's really nice to teach and to try to guess and to understand what's going on, because you can tweak some parameters and then you see your computing increasing or decreasing, and then you try to feel what's the problem, because in this kind of problem everything matters. So you have to take care of the vectorization, of the cache, of the alignment of the data, everything. Otherwise, you will have a problem of performance. So we can dive into all the aspects of the optimization with this simple project and these simple equations. In terms of language and technology for 2026, we will have C++, Fortran, and Python. So unfortunately, Adrien has less time this year, so we decide to avoid the Rust lectures because Adrien does not have time to make it really well as he wanted to. So we'll have a little pause in the Rust lecture, but don't worry, we'll come back in 2027, of course. Everything is scheduled, so there is no problem for that. So in terms of computing, on CPU computing, we will also address NUMA, as we did last year. And we will use mainly TBB, EV, and Cocos, also a bit of OpenMP, a bit of some surprise also. I don't want to spoil everything. Then Fortran with do concurrent stuff with using TBB behind under the hood, and Python with NumPy and Numba. And then for the GPU part, we'll have CUDA and Thrust as always. We'll have HPC SDK also, Cocos on the part on the GPU part. So Cocos will be made by a team in Maison de la Simulation, so in the CEA, so with Pascal Tremblin. So I asked him, and he will be glad to join the school. So also David has less time this year, so we will not have the cycle lecture, but we replace it by the Cocos lecture. So normally both 2025, 2026 school will be much complementary, so could be quite nice. In Fortran also, the do concurrent with NV Fortran will be used, and then Numeric legate in Python, and PyTorch and JAX and CuPy also for the GPU computing in Python. So then we will have tools, as always. So performance test tools, so Valgrind, Perf, Macao, and Site. Memory profiler tools, so Malt and Numap. And the news also that we have is Malt now is capable to profile Python in a much efficient way. So if you have some Python trouble with memory, you can also have a look. So we will have one seminar, and we will have a dedicated lecture on that on the school. For the compiler, we will have LLVM compiler, so Clang, Clang++, and Flang. For the new compiler, so GCC, G++, and GFortran, of course, NVIDIA, NVC++, NVCC, and NVFortran compiler, and Intel ICPX and DPC++ compiler. Then we have some precision with KADNA, and the classic triplet with a Git, GitLab, and CMake to compile everything if needed. Then we have a multi-site diffusion, as Marie said at the beginning of the webinar. So we have the lab in NC. So we have all the teachers, 9 teachers in NC. We have about 40 people here. So we stream everything live on YouTube and on Discord, and we have one Bootstrap day and one extra day also for people attending the school in NC. But we also diffuse all the school in lots of satellite sites. So here are the satellite sites of 2024 and 2025. I would like also to thank them for their support and to attend the school, because it's quite a lot of work, in fact. So we have satellite sites in Toulouse, Marseille, Nantes, Rouen, Compiègne, Reims, Amsterdam, Stuttgart, Brussels, in Morocco, in Senegal, in Ljubljana, Sofia Antipolis, in Luxembourg, and in Paris, so Ile-de-France. So many thanks for them to participate to the school. Of course, if you want to be sure that your favorite computing center will participate to the school, you can ask, you can send us a mail or ask in the chat if you want. So we'll be glad to take you on board. There is no restriction. So if you want to participate, no problem. Just ask, and we will do our best to make sure that everything will be smooth for you. So it's a bit of work, of course, but you can form your people, you can train your people, or you can have some guests, or you can open your door, you can follow whatever lecture you want. You are not obliged to follow the 2 weeks if you don't have the time. It's better, of course, if you can, but if you cannot, we can understand. Of course, it's quite heavy. And if you are not involved in a computing center, but you would like to have your favorite computing center involved also, you can ask us also to be sure that we do our best to have as much computing center as possible. And even if you don't have a computing center, maybe you have an auditorium and you want to follow the lecture with some colleagues, it's okay, and we can register you as a satellite set, even if you don't have computing power. You can follow everything on your laptop. It's not a problem. And speaking of that, how to follow lectures. So basically on your laptop, if you want, you can follow the lecture on YouTube and with the lecture on the web. So everything is available. And then you have the installation in bare metal if you want. So if you really want to have a bare metal installation, I really have to recommend you to use Pixie. So you will be able to really manage your installation really really easily. So we can you can try it if you want. If you prefer, you can also use containers. So they are compatible with Obtainer, Security, Docker, Podman. So normally everything should be okay. So we have interactive container for the laptops or for the remote server. You can also use Must, so the computing center at lab. So you can use Docker with Kubernetes and Jupyter Hub. So we have a teaching platform with all the lecture available of Grace Code, so 2024, 2025, and soon 2026. You can also start some jobs with Obtainer, with htconda also. So we have dedicated container with less dependency, smaller containers, so it's faster to deploy, faster to use, and there is no interactive stuff in it, because it's not the point to have a job with interactive stuff. So it's also possible to do that. And if you want to use one satellite site, you can, maybe you will for sure use Slurm normally. It's quite a standard for an HPC center. And again, you can use a light version of the lecture to be sure that we will not mess the computing center. It's important also for the security. So in terms of hardware, we will have Intel, AMD, and ARM available with NVIDIA and AMD GPUs if you want to use them. Normally, no problem. And now I will present to you a bit Pixie, for those who don't know what Pixie is, with a bit of history. So back in the day, more than 10 years ago, we had Anaconda. And the idea of Anaconda was to have a rootless installer and something common, a generic package format for all languages, so you don't have to be bothered with pip, with UV for Python, with the Fortran package manager for Fortran, with APT, with APK, with Pacman, with all these kind of installer for all the library. You don't have to be bothered with all languages coming with its own installer, and it's really a mess once to mix things up. Here it's really simple. But of course, a big problem was it's a rootless installer. So it's a big security issue. And once Anaconda was released, a lot of system administrator had heart attack because, of course, it's a big security issue, and you don't want the user to be able to do everything you want. Of course, it will be a catastrophe if you do that. The main problem with Anaconda, it was a company, and of course, it was not the open source community would disagree on that, of course, and they try to avoid it and create Conda, so an open source rootless installer with the generic package format, which is a good idea. And the game changer here was Conda Forge. So on Conda Forge, you have all the packages you can imagine. So everything. There is something like 55,000 packages available. So normally, if you think about a package, it should be available. If not, you are really unlucky. The point is, with that, we have a growing community because it's really easy to use the package. It's really easy to create environments. So things get growing. But the problem is, once a community is growing, you have people with maybe less care about size of the environment or splitting of the environment, on quality of the environment, and then you have to use really huge environment with a big mess inside it, and you don't really know what is useful and what is not. So it's quite problematic. And at the end of the day, the big problem of this environment is you kill your distributed file system because you have tens of hundreds of files in your environment, and the distributed file system is really not designed for that. So you have big problem on that. Another big problem was Conda was developed in Python, and Python is really, really slow. And you get some really cryptic errors, and Conda is stuck for 20 minutes. And after 20 minutes, if you are lucky, Conda will crash and say to you, okay, I cannot solve your environment. And you say, okay, but what's the problem? I don't know. I don't know the problem, but it's not working. And yeah, it's with big environment, it's really difficult to do that really nicely. So it was a limit, a big limitation of Conda. So people try to step up and say, okay, it's a good idea, but we have to do something really better. So Mamba comes in the game. So they redevelop a Conda installer, but in C++. So they try to make it lighter and faster than Conda. And they improve also the feedback once there is some problem. Then they released also MicroMamba, so it's an installer, but you don't have the default environment, the crazy 10 gigabyte default environment of Anaconda, for example, which is quite a shame, in fact. But still, there is some problem. You have sometimes some cryptic error, and you don't know really what's going on. And it's way better than Conda, but sometimes, yeah, it's you have some trouble. So the same team of Mamba said, okay, we learn a lot with this installer, so let's rewrite everything in a language that you might guess, I think, in Rust, of course. So here comes Pixie. So they redevelop a rootless installer in the open source community, of course, but to have something fast with really clear error, they are really, really clear. And they add also a package builder inside Pixie. So you don't have to be bothered with an ugly bash script to create a Conda package with Conda Forge. You just have to ask Pixie, hey, create me a package with my configuration here, and that's it. And it's really, really nice to use, in fact. And it's not done yet because we have another thing coming with Pixie, which is prefix dev. So it's a mirror of Conda Forge. So everything in Conda Forge is available in prefix dev. And their goal is clearly to replace Conda Forge at the end with something really more robust and clear. And you can also create your own channel on prefix dev and push package on it as you want. So what is the philosophy behind Pixie? So everything starts with the sources, of course, and then you describe your project with a configuration, so a pixie.toml. And in the pixie.toml, you said, okay, I want my dependencies, I want my this and this environments, I want to describe my tasks, and then you have one file to describe your whole project. And also you have another good idea is the pixie log file. Of course, if you did some Rust, it's completely inspired by the cargo log file. So here you have the pixie log file. So it's not quite the same implementation, but the same ID. And you get exactly the full description of your environment. So exactly which package you use, which hash of the package, which URL of the package, exactly to recreate exactly the same environment. If the packages are available, of course, but here you have this guarantee. It's not possible with Mamba. It's not possible with Conda. You have some tricks to try to mimic this stuff, but it's not as good as this one, and this one is really, really good. And the philosophy behind Pixie is not to have a separated environment from your project somewhere, and then you forget and you create another environment and you waste your disk space because you have a duplicate of your environment. The idea is to have the full environment inside your project. It's not commit, of course, but it's in your project. Your project has its own set of environments. And then once you are in your project, you use automatically the good environments. You can also do some workspace as in Cargo, of course, but that's another story. The main point is once you want to commit, you commit everything. You commit your configuration, you commit your sources, and you commit the log file. So if you want to go in the past for some reason, or you want to change branches or whatever, you have your lock and you can recreate exactly the same environment. So for example, if I do a change with my laptop and I want some colleague to be able to check, the colleague can get exactly the same commit, create exactly the same environment with the same lock, and see if we can reproduce a problem or reproduce the fix of a problem or stuff like this. It's really powerful. Again, we can do the same on a computing center, on Must, for example, and you get exactly the same environment. So it's really nice also to debug, or for the production, you don't have to try to get roughly the same installation, but not really, and you don't have the same result and you don't know why. Here, if you don't have the same result, it's your fault. It's not the fault of your dependency. And also we have GitLab, so we have an integration, continuous integration pipeline, so we can create binary package on the fly once we do a release, and we can push packages on prefix dev. So we can directly get the packages, binary packages, on a laptop of your colleague, on a computing center. If you want to do a production or you want to do a test, a really small test, it's your program, it's your way of doing things. Normally, no problem. And a last really important point with Pixie, I mentioned it several times, why splitting environments? It's important also to have that. We'll do also the focus on the school on that. It's nice to have the faster program in the world, but if you cannot deploy it, it's not really nice. So let's try to do it properly, and we'll dive into it also in the school. So to give you some example with my lecture on C++17, C++20 for 2026 for the Grace Code reaction, I have a production environment, so really small environment for. We have the final executable for the simulation. We have some dependency like HDF5 to store the result, libpng to create the images, and TBB for the parallelization of the computing, for example. But also, yeah, it's quite really small, and we need some stuff to put on top of it to be able to test, for example. So for the test environment, I can use compilers, so G++ and Clang, and can use a builder with CMake, Make, and Ninja. I can use Valgrind and Macao to check if the vectorization is nice, if the memory is quite well used, and can use gcov and gcov to check the coverage of my test, because of course I have some tests, but the test I represent only 3% of my project. I do not test my project. And finally, I can have a development environment with interactive tools. So I can have my GDB, I can have Valgrind, I can have Insight, for example. So all the interactive stuff. So of course, this is a really big environment. So for 40,000 files, quite huge, and 1.3 gigabytes. So not that huge in terms of weight, but a lot of files, and that's a problem. So it's nice because I can debug, I can really check all my stuff. But the problem, of course, is it's really heavy, it's complex. Maybe there is some graphic interface, or there is X11 or Wayland involved somewhere, and you have a lot of security issue with that, and you slow down your distributed file system in the best case, or you kill your distributed file system if you don't worry too much about that. So quite too much. For the test environment, 18,000 files, 1.1 gigabyte, better, but quite heavy. And the production file, we have 5,000 files, 140 megabytes, quite reasonable. And the point is, it's really fast to deploy. You have less complexity, less vulnerabilities. And if your favorite system administrator wants to check if you can use your program on the computing center, it's really easy for them to check also. You don't have to say, okay, no way, the environment is too big. Here it's really simple. You have several dependencies. We can check easily. So it's important also to be transparent with system administrator. So that being said, I really want to thank all the sponsors for 2025 edition. So Codrecon, Intel, Eviden, Eolen, Duitna, and Carnot for the support on the school. So clearly we cannot make the school without their help. So they also provide us some access to computing center. They give us also some engineers for the Bootstrap. So many thanks also to Loris and to Stefan, who attend the school for the Bootstrap in Annecy and in Toulouse. It was really nice of them. So many thanks to all of them. It was really a pleasure to have them on board, and we hope that they will stay on board also for the 2026 edition. And then you can ask me, okay, what's new in 2026? So first, until 2025, what we did is to use CPUs and to use GPUs. And now what we want to do is to say, okay, let's use both GPU and CPU. Let's use all the CPUs available and all the GPUs available in a blade server, basically. And with advanced algorithm, so last year we present to you the pyramid algorithm. So for CPU, here we will present it to you a bit modified version for CPU and GPU. So for C++, for Fortran, and for Python. So how to deal with that, how to optimize the memory usage in CPU and GPU, because it's quite the same idea, but not exactly the same trick under the hood. And so the main point here will be, how do I use the full blade server efficiently? So I use all the GPU available, all the CPU available, and I try to do my best with everything. And of course, we will also have a part of the deployment. So how do I deliver something? How do I create my container or my package to be sure that everything is nice and reusable? Because of course, if you have the fastest program in the world, but you cannot deploy it and you cannot share it, it's quite a pity. So let's try to step up also on this quality. And in conclusion, so Grayscale School will be from the 22nd of June to the 3rd of July 2026, so in summer. So it's for students, for researchers, for engineers, for developers, for everyone. If you want to, basically, if you have something to compute and you want to be able to have a panel of technologies that you can use for your problem, and you want to check some languages or some technologies, it's the right place to be. Then you have link to the school, so the CCFR site, you have the timetables, you have the webinars, and you have the Discord, the Grayscale Thursday on 2035, if you want to have a look of what we did last year, the live of 2035, so the the 90 hours live if you want to have a look of the mood of the school, and the edited version of the school for the 82 videos of 2025. So you have lectures, you have interviews of the teacher, the attendees, to see what's going on and to see how they approach the school. So it's quite nice also. And I will dive into this link to give you a little view of what's going on. So here you have the page of the school 2026. So if you want to register, here you have a brief description of the school, and you can have here, you can register for the school. So don't miss it if you want, especially if you want to come to Annecy, because it will be quite difficult as always to have an apartment or to have an hotel for this year. Don't waste your chance if you want to go. Then you have all the webinar here, so you can register for all the webinar in one click. So basically you have the link, and you can check all the webinar you want to attend, and you will have a global invitation for all the webinar. You get the agenda here, and you have all the stuff that we will use, practically all. In fact, we have some surprise for you, of course, as always, but mainly you have everything here, and the program here. So I will jump on the program. So to give you an overview of the program, so as last year, we have the first week on CPU computing, the second week on GPU computing mainly, and then we will start, as always, with introduction of the Grayscale schools, CPU architectures, what is vectorization, parallelization, what is compilation, unit testing, then C++17 on the CPU with the advanced optimization, so the pyramid algorithm that we presented last year. But of course, we'll push a bit more the boundaries of this lecture. It was maybe not really the second part, because we start from the beginning as last year, but we will go way further than last year. Then the profiling tools, so basically Valgrind, VTune, Perf, stuff like this. Then Fortran, so how to use Fortran 2018 on CPU, so with coarrays, with all this kind of stuff. Memory profiling, so Malt, Numap, Prof, how to use them. Cocos on CPU, so it's a kind of a mirror of the C++ lecture. So here it's I have nothing, I want to understand what's going on, and here I have a framework. How do I use it? In which purpose? How can I get the best performances on my CPU with design, with everything you want to use? Then precision, because it's important to compute fast, but if you compute accurate, it's better. So you have to understand the precision you want. So it's really also important to have this one. Python with CPU, so NumPy, Numba, all this kind of stuff here. And then the impact of the system on the system or your performance. So of course, you optimize as much as possible your program, but at the end of the day, the operating system does the allocation, and sometimes it's not really efficient. So sorry. So you have also to understand this kind of stuff, and why you should have some problem and how to solve them also. Then a little shifted hands-on. So it's made by Sébastien. So the idea is to make you program something from scratch. I will not spoil the subject, but you will see it's really, really nice. And you will enjoy it, I'm pretty sure. And then question to the teacher. So only for ANSI here. So mainly all the teacher on the stage, and you ask your question to us. So we had a lot of interesting questions. It's we have questions like, how do I get involved in the HPC community? How do I get a job? How do I convince my boss to do something with quality? Every kind of stuff. So it's up to you to bring your question. It's always really interesting, and generally it's maybe a bit more than than 4 o'clock because we have some difficulty to stop. But yeah, it's up to you to bring us a question. Then the second week, so we start with Eve and a bit of Kiwaku also with C++20. for CPU computing, and then we dive into GPU computing. So GPU architecture, how does it work, how to use them efficiently, and then example with C++17 with NVC++ and a bit of CUDA, but I think I will maybe I will highlight the NVC++ stuff because I did a bit of CUDA also last year, so I think I will change a bit. Not to do the same stuff twice, of course. Then Python, so CuPy, QNumeric, JAX, and PyTorch. So everything you want to know about them. Then Fortran on GPU, so with do concurrent with NVFortran, with a bit of Fortran CUDA also, if you want to use them. Julia, we have a seminar on Julia. We don't have time for a full lecture, but we have a nice webinar, nice seminar of Julia from Nabil, so it's involving also in the GPU part of Python. And then the Cocos version of GPU. So how to use Cocos with the Grayscott on a GPU with a nice way. Then we end with a story about cubic root optimization. So in C++ and in Fortran, so we did that with Vincent. So the idea is to put everything you saw in the 2 weeks and to show you how to do that with another example. So cubic root optimization. So basically how to have something faster than the math library with a better accuracy, and how to do that with which tools, how to use them, stuff like this. Quite nice also. And then for the first time, we'll have a closing presentation, and we will present to you also what's next, because there is a plan. So you will have also the next step of the plan for the school at this point. And then we finish with the Bootstrap day. So in Annecy and normally in Toulouse also it should be possible. So basically you attend with your question, and we do our best to answer for your particular problem, your particular simulation or data analysis or whatever question you have in terms of design, in terms of language, in terms of architecture, in terms of optimization, whatever you want, even in terms of algorithm, it's not a problem. So as you want. And I will finish with the webinars. Here you get all the webinars in 3 rows. So this is the first one, of course. Then next week we will have unit test webinar. So the philosophy behind unit test, how to do it. It's much more than, rather than checking that the result is okay. It's you can get much more than this. So it's important also to address that. CPU architectures, computing precision, memory allocation. So then how to profile the allocation of your program, how to find why there is this allocation of this size for whatever reason. The modern C++ computing, so maybe what to do with LTD algorithms, so std for each, transform, all this kind of stuff, with the news that we have with the last compiler, of course. Then Fortran on CPU. Then we have a little break because it's GTC, and so in GTC, I follow the GTC, so I want to sleep, so there is a break here, sorry. And then GPU architectures, Fortran GPU, modern GPU with C++, so std algorithm for GPU and CUDA also. Then Cocos, then Eve, then somewhere there will be a day out in French, something like that. Then Python on CPU, Python on GPU. So it's 2 weeks from each, 1 week from each other, but it's life. It's just a matter of agenda. So we do our best each time. Cocos on GPU, the feedback of the GTC. So I give you, as every year now, I give you a feedback of all the presentation I saw in the GTC. So in 2024, it was something like 90 presentation. 2025 was more reasonable. It was something like 60 or 70. So we will see how much presentation I can see here. And then some technical question to end the webinar. So if you basically to show you how to use the lecture, how to get the lecture in remote, in live, in your favorite browser, in all the kind of stuff you want to use. And speaking of that, you have also here some advice. So for mainly the lecture of the last year, because we did not upgrade all the lecture yet, but it's ongoing. So if you want to know how to use the container of your laptop, you have a demonstration here. If you want to use on a remote server, you have also a demonstration here to use it with SSH. For the job submission, if you want to use htcondor, you have also documentation here. You have the documentation for Slurm with Maisonette documentation. So they did a great job also if you want to get involved and to use Slurm on your job. It's also nice. Then for Kubernetes, for our formation platform here, you get also how to use the formation platform, how to dive with your favorite browser into the formation platform, and how to compile, how to use example and stuff like this. So it's okay if you want also to have a look. And then the timetable. So I will have to update a bit the timetable. It's a timetable from last year, of course, because all the lectures are not ready yet. They are practically all ready, but not all. So the three container, as I said before. So you have a light image if you want to send some jobs. You have an interactive image if you want to jump on your laptop, for example, with your favorite browser or on a remote server that you own. So you have a nice editor inside the container. Then you have the Jupyter Hub part. So if you have a Jupyter Hub instance, so we have one on Kubernetes for Must. If you have the same, I know in the Maison de la Simulation they have also this kind of formation platform. So if you do have one formation platform like this on your favorite computing center, you can use this kind of container and bring them to your user. No problem. It's designed for that. So you get that for all the lecture here. And you can also have a look to the Rust lecture if you want, because we will not have a Rust lecture in this school because we don't have the time. In fact, Adrien does not have the time to make a lecture of the quality that he wanted. So we agree on the fact that okay, let's wait 1 year. It's only 1 year, so not a big deal. And then we have all the satellite sites of last year. So I hope we can have some satellite sites also for this year. If you want to have new satellite site again, try to ask us to make us in touch with your favorite computing center you want, or just the laboratory you want, or the auditorium you want. You don't have to have big computing power to attend the school. It's not the point. Of course, with a simple laptop, you can follow the lecture. Of course, it will be better on a Numa lecture, for example, to have a server. But if you don't have one, you can follow either. It's not a problem. And I think that's it. So maybe I can finish with one question if you want. So as I said, unfortunately, we don't have a Rust lecture in the school. We can give you a big seminar, a big webinar on Rust if you want. So if you are interested in this webinar, we can add one webinar. We have a bit of margin this year. We have a bit less day out in Thursday in French this year. So if you want, just ask us and we can add a webinar for that if you really want to have a look on that. If you don't, it's not a problem. You will have a webinar as usual in 2027. But for this one, if you want, it's up to you. And thanks for your attention. If you have some question, ask them into the chat, and we will do our best to answer them. Thank you. Okay, question from Luca. silly question regarding Pixie. When doing G++, Clang, etc., does Pixie install the compiler as well? Yes, it's automatic. In the build environment, it's automatic. Normally, they plan to be able to change the compiler if you want. You can change it if you want, but for now, it's automatic. You have a backend, so a CMake backend, a Python backend, and the compiler comes from this backend. But yeah, you can for now it's automatic, so you cannot really do what you want. What if there is MPI? You can install MPI also with Pixie. There is no problem. Also follow up to that, does Pixie supersede containers? Yes and no. Their goal at the very beginning of Pixie was to completely avoid containers and do something reproducible without containers. In fact, what we do is a bit of a mix of the two. For the laptop, we use Pixie without containers, but for the deliverable, what we do is we use a distroless container, and then we install Pixie inside it with a multi-layer installation, and we create the environment, and we keep the environment as the main environment for the final deliverable. So you can build really small container with Pixie. It's really nice, even if it was not the goal at the very beginning. But it's it's a good point also. So it's not exactly, or just a different logic. It's not exactly the same logic, because in fact, with the Docker file, you can specify all the hash, all the version of all the images that you want to use. But at the end of the day, you will install stuff with APT, with APK, with Pacman, with whatever you want, and you don't have really the hand on exactly which version you want to install. With Pixie, you have the lock, and you can say, create me this exact environment, and you don't have problem. For example, if you want to use Mamba, or if you want to use APT, APK, whatever you want, and you want to have 3 environments, so one production environment, one development environment, and one test environment, you will struggle to have exactly the complementary environment. With Pixie, you can say, I want exactly this version for my production environment. On top of this, I want to add this version for my test environment, keeping the same version for the other dependency of my production environment, and do the same for the development environment. And you have the control. If you want to do that with Mamba, for example, you have to do some ugly tricks. So you have to build your development environment first and create a YAML with all the version, and then split the YAML into several pieces to create exactly the same environment in the other way. It's quite ugly, and you don't have the guarantee that it will work at the end of the day. So it's not exactly the same logic as always, because here you don't have the environment is inside your sources, inside your project. So you have the hand on it. It's not somewhere on your system and you don't know what's going on. So thank you for the question. This school is free. Of course, I forgot to say that, but the school is totally free. So don't hesitate to register. It's not a bug, it's free. So the point is, if you want to attend the school in Annecy, for example, since there is no fees and since it's free, it's better if you can tell us, okay, we have an apartment, we have a hotel, and we invest something to guarantee us that we will come, because otherwise you say we'll come and then you don't come, and then we have an empty place for someone who potentially could have come. So it's better to be transparent on that. So you have the link of the Discord here. Question from Richard. So please, can you clarify the advantages of setting up a satellite site, given that it's easy to follow remotely anyway? I understand that the Q&A session will the lecturer exclusively for participants. No, everything is live, even the answer and the question and everything. It's just if you, so as Karim said, it's for your community if you want. So if you want to participate as a satellite site, you can form your people, your colleagues, or other people, or to make some publicity about your computing center, to create some partnership with other company of whatever you want. So it's at the end of the day, it's your school. You follow what you want, you attend what you want, and you open your computing center or not for whoever you want. So it's up to you. So there is some lecture just for ANSI, so for hands-on session or discussion or Bootstrap, stuff like this, but everything else is for everyone. And it's live, it's on YouTube, it's on Discord, so you can get all the information. So no problem. So Luca is happy. I'm happy that you're happy. It seems that Pixie is more user-oriented. Yes. Is it possible to share environment between different users? Yes, it's possible. We do that, in fact, in Mus. You can do that. It's not exactly the way it's thought at the first time. You can, as an administrator, create a shared environment, as we can do in Mamba, for example, but you have exactly the lock of your environment. So it's totally possible. It's not really the philosophy for Pixie. It's user first, if you want, but you can create share environment if you want. Yeah, it's totally possible. You have Pixie global install if you want to do that. So it's totally possible, and you can use it, no problem. Yeah, totally. If you want to deliver a virtual environment for users, you can create a Pixie global install with exactly the version you want, exactly. And if you have another need for another user, you can create another environment with exactly some different version or totally other stuff. No problem. It's designed for that. Then David has a question. Thank you for the presentation. Another question, but Pixie. Okay, so it was a nice point to present Pixie after all. From what I understand, it can do the same as SPAC. What would be the main difference? I don't use much SPAC, but as I understand, SPAC, you have the kind of layers in your packages. Pixie, it's more than environment, but it's quite the same idea. You can build environment on top of each other. In SPAC, you can build layer on top of each other. So it's quite the same idea, but I'm not sure if in SPAC you can have really the lock and get exactly the same version. I'm not really using SPAC much. So I can ask some colleague who are using SPAC a lot, but me, I use not so much. But or maybe just a catalog. Maybe you have less program or less project in SPAC that you have in Pixie. Maybe not. I don't know. We have to check. But it's quite the same idea. In fact, yeah, you want to have something really close, and you say, okay, it's my environment. I don't want something to be linked to another stuff, and I don't have the hand on it, and maybe it will break. So it's quite the same idea. Not exactly the same solution, but quite the same idea. So I guess, yeah, if you're familiar with SPAC, maybe you can check Pixie, or if you're familiar with Pixie, you can check SPAC to get the best of both worlds, if you want. So from David, okay, thank you for your answer. I didn't know Pixie at all. Pixie is really young. Pixie, I think it's 2 years old, something like that. So it's a really young project. It's still in beta, but even in beta, it's really powerful. So now it's so yeah. In fact, we use it already for production, even if maybe we shouldn't, because it's an alpha version. not a free release yet, but it's on the way. Normally, this year we should have a release or a year after. But it's really powerful, even if it's not a final release project. Didn't big at all. I'm going to try a simple project to get to know a little better. Yeah, so it's the same idea as Cargo. So you can do a pixie init, and you will get your default toml pixie, and then pixie add the name of the dependency. So for example, pixie add numpy, pixie add the CMake, pixie add make, whatever you want. And you can create your environment like this, and pixie will automatically add the dependency into your toml, your pixie toml, and you can have a look like this. So it's a bit more complex than Cargo because you have several environments, you can split a lot of stuff, you can have tasks, you have a lot of stuff, but it's quite the same idea. If you are familiar with Cargo, normally with Pixie, it's not a problem. The documentation is a bit messy sometimes, but it's ongoing as always. It's a really young project, so it's not really a problem. It's just you have to get used to. But if you use Pixie and you use Pixie help, you have normally all the information you want. So normally, if you want to give it a try, there is no problem. We'll have a little session, I guess, in the school also to present Pixie more, because we realize that we have, in fact, more people that want to have a bare metal install. Last year it was something like more than 50 or 60 people using a bare metal installation, and with all the problems that come within. So which we said, okay, let's try to use Pixie because you have your bare metal installation, but you don't struggle with version, with where to install stuff, how to install stuff. So it's quite nice to have. So question from Theo. It looks like UV, but not restricted to Python. Yes, it's the same idea. So UV is a pip of but it's a pip written in Rust if you want, but it's a working pip because pip is a big mess, and UV is quite more straightforward in terms of that. But yeah, it's the same idea, but you can have all the Conda package, all the Conda Forge environment, all everything. So it's the same idea. If you want to do only Python, UV is simpler. But if you want to be able to do some Python stuff, some wrapping, some C++, some Rust, if you use Pixie, it will be much better, much simpler for you. So yeah, it's totally that. Yeah, thank you, Theo. Yeah, to give you an idea about Pixie, because apparently you are really curious about Pixie, we use Pixie in production since a bit more than 6 months now. And so at the very beginning, we had a classical CI integration with containers, and we build stuff on the fly. And with Pixie, we try also to do the same and create, get the package on the fly, install them, but not recompile them. And basically, from switching to full container to Pixie inside container, we divided the length of the workflow by a factor 3. So basically now one integration pipeline is roughly 1 minute, and before with the old way of doing things, it was maybe 2-3 minutes. So it's quite a nice stuff. In fact, it's an investment, so we try to do it our best. And at the end, yeah, we have really smaller pipelines, so better to debug, better to deploy, better to get the feedback, better to get the release, and everything is faster. We consume less energy also, so yeah, it's really nice to have this kind of stuff. Maybe Karim, you want to add something?
No, I'm just looking if we have more question.
Okay.
I don't know, so perhaps we can make the conclusion. I don't know. Okay, first, I want to thank you all for your participation. if you have any question about how to participate or why to become a satellite site, we can organize with you a dedicated meeting to discuss on the collaboration, because we want to make it like a European school also for the EuroCC project. So don't hesitate to collaborate with us, because we are going to share all the KPI also of the attendees. So don't hesitate to contact us if you want just to have more information on this collaboration. We hope to see you again on the different webinar we are organizing. So for me, just want to say thank you very much, Pierre. Thank you very much, Marie, for all the organization. And I hope to see you again soon. Thank you very much.
Maybe also to complete, if everything goes according to plan, tomorrow afternoon you will get the replay on YouTube. So if for some reason you want to share it with some colleagues who cannot join today, or for all the other webinars, normally the Friday afternoon you will get, or even Friday late morning, so around 11, 12, you should have the replay available on YouTube.
Of course, there's no question. Everything will be online.
Yeah.
And we hope you enjoyed it as much as we enjoyed organizing it, and with a great Scott School team. So happy to have you on board. And thank you, Pierre, for this great presentation.
Thank you, Marie. Thank you, Karim, for coming and for supporting us after all these years, in fact.
It's always a pleasure. See you soon. Thank you all. Have a great day.
Bye, and see you next week for the unit test webinar.
See you next week. Bye, everyone.
Bye.